Hey guys, and welcome to the next section of the course. You'll learn all about conditional statements, if, else, elif, logical operators, nested blocks, arithmetic comparisons, string comparisons, case statements, and a whole lot more. You'll even be able to create bash menus, and this will boost your system administration automation skills. By the end of this section, you'll be able to add logic to your scripts and create really useful stuff for your daily jobs. Okay, let's get started. In this video, we'll discuss if, elif, and else statements that are used for decision making, which is one of the most fundamental concepts in computer programming. This is program flow control in general, which allows us to have logic in our scripts and execute a section of the code only when some criteria are met. Here, if, then, elif, else and phi are bash reserved words, and the sum condition is usually some sort of comparison operation, like say for example testing if the value of a variable is greater than a specific number, if an argument of the script is either a file or a directory, or if you have the read permission on a specific file. Basically, this code says something like this. If the first condition is true, then execute only this piece of code below. If the first condition is evaluated to false, test the second condition that comes after elif. If the second condition is true, then execute only that block of code, but if it's false, execute the block of code that comes after the else clause. The conditions are evaluated sequentially. Once a test condition returns true, the remaining conditions will not be evaluated anymore, and the program control moves to the end of the if construct, so after the phi line. Phi is if written backwards, and ends the if construct, which is in fact a shell compound command. Remember that each bash compound command starts and ends with some reserved words, if and phi in this case. And by the way, in bash, true means a return status of 0, while false means a return status different from 0. Note that you can have only one if statement, and it's not mandatory to always have elif or else statements. Also note that it's mandatory to have a white space before and after the square brackets that enclose the testing condition, and the phi reserved word at the end delimits the entire if, elif, and else programming structure. It's similar to a closing curly brace in other programming languages like C or Java. Let's go to coding and see some examples. I'm creating a script that takes a regular file as an argument and displays its contents. So cat $1. I remind you that $1 is the first argument of the script. I'm saving the file. I want to avoid opening the file, changing, closing, and then running the script each time I add or modify something in the script, so I'm gonna split the terminal horizontally in two. In one window, I'll see the script, and in the other one, I'll run it. I'm setting the execution permission for the script. And I'm running the script, giving it a regular file as an argument. Great, but what will happen if instead of giving the script an existing file as an argument, I give it a directory or a non-existing file? In that case, the cat command will return an error. I'm giving it a directory as an argument, and it returned an error saying that /etc is a directory. And now I'm giving the script a non-existing file. That means some sort of testing is necessary. I want to display the contents of the first argument of the script only if that argument is of type regular file. So I'm adding an if statement with a test condition. If white space, a pair of square brackets, and in square brackets dash f $1 in double quotes. Then and phi. Dash f is a test condition that returns true if the value that follows is a regular file. So if $1 is a regular file. That means that the piece of code between then and phi will be evaluated and run only if $1, so the first argument of the script, is of type regular file. I'd recommend you to use indentation, as I did, to increase readability. I'm saving the file. By the way, if you want to see all the testing conditions that can be used, then run man test. And you'll find here all the testing conditions that can be used. A final remark about the code you see right now is that I've enclosed the $1 variable in the test condition in double quotes. Do you know why I did it this way? As we've already discussed in the last section, the result of an expansion that didn't occur within double quotes is subject to word splitting. And I used double quotes because I don't want the result of the $1 expansion to be subject to word splitting. This way, it allows white spaces in the file name. This is a small detail, but it can make a difference in some cases. Please take another look at the video where we discussed word splitting if you feel the need. In just a moment, I'll show you another way to prevent word splitting. Let's run the script again, giving it a directory as an argument or a file that doesn't exist. There's no error, and now a directory. And there's no error because the cat command was not executed, since the test condition returned false. Let's move on and add a second test condition. If the past argument is a directory, not a file, then I'll run ls-l on it. So I'm adding a message, echo, the argument is a file, displaying its contents. And sleep on. I'm pausing the script for 1 second so that the user has enough time to read the message. And I'm adding the second condition, elif, square brackets, and the test condition, -d, $1. Don't forget a space before and after each square bracket. And now the block of code of the elif statement. Then echo, the argument is a directory running ls-l. Sleep 1 and the ls-l $1. And I'm also adding an else clause. Else, echo, and it will display the message, the argument, $1 in parentheses, is neither a file nor a directory. I'm saving and running the script. I'm giving it a directory, and it listed the contents of the directory. Now I'm giving it a non-existing file. And if I give it an existing file, it will print out its contents. Great. Finally, I want to tell you something about single square brackets versus double square brackets. The example shown in this video use single square brackets for test conditions. This is the old classical and portable type of testing. There's a new updated version of testing that uses double square brackets as they are considered safer. I'm changing single square brackets to double square brackets. Basically, double square brackets prevent word splitting of string variables that contain spaces, and you don't need to double quote string variables, even though that's good practice. Double square brackets also have some other nice features, like regular expression matching. For the moment, don't focus too much on it. You can use double square brackets if you don't know what to use. Alright, that's all about if, elif, and else statements. In this video, you've learned what the if statement does and how to write an if, elif, and else construct. Now you can add logic to your scripts, which is the key to providing efficient automation. In the next video, we'll dive deeper into script flow control and cover arithmetic comparisons. So I'll see you in the next lesson.